Okay, this is the fourth video, and we're going to start with number 39, which I didn't do in the third video. So now I'm going to look at it again. And it says a vowel given that it is in the word geometry. So the only one of the first 10 letters in the alphabet that's in the word geometry is one out of a total of 8 letters that's in the word geometry. Here, I have to count the number of consonants that are in the first 10 letters, and there are 6 out of 10. And so that simplifies to 3/5. And before E in the alphabet, so that's 1, 2, 3, 4 out of 10. So that would be 2/5. And then the last one, it says in the word sidewalk. So I have 1, 2, 3, 4, 5, 6, 7, 8, 8 letters in the word sidewalk. And 1, 2, 3, 4 of those letters are in the first 10 letters. So that it would simplify to 1/2. So let's flip the page and move on along to number 44. And this is just saying, refer to a bag that contains 6 blue marbles, 7 green, and 3 red. So that would be a total of 16 marbles. What is the probability of selecting a red marble? So that would be 3 out of 16. What is the probability of selecting a red or a green marble? So or means plus. So 3 out of 16, or the probability of a green is 7 out of 16. So I am going to just add those up, and it will be 10 out of 16, which is equal to 5/8. What is the probability of not selecting a blue marble? So I have to say that there are 6 blue out of the 16, so that's going to be, the possibility is going to be 10 out of 16. So, because it's the not situation, you have to take all of the other marbles that are not blue and add them together. So what is the probability of selecting a green marble, replacing that marble, and then, so and means multiply, selecting a blue marble. So these are independent events because I replaced it. So it says 7 out of 16 is the probability of a green, replace it, and then selecting a blue, times 6 out of 16. So I take my calculator, 7 out of 16, and multiply that by 6 out of 16. And your answer is 21 over 128. The next one, what's the probability of selecting a green marble without replacement, and then selecting a blue marble? So we're so green marble first. Again, we are 7 out of 16. Now this time we're selecting a blue, but we're not replacing that marble. So these are dependent events, and so I have 7 out of 16, and then I multiply that times, because there are 6 blue ones out of a total of 15 now. And your answer should be 7/40. What is the probability of selecting a blue marble and then selecting another blue marble without replacement? So the first time I select a blue marble, 6 out of 16. The next time I select that blue marble, because we haven't replaced it, it's 5 out of 15. So I can simplify it to be 3/8 times 1/3, so it would be 3/24, and then that would be 1/8 would be my final answer. But you can plug it into your calculator if you'd like. A coin is tossed. What is the theoretical probability of getting a heads? Theoretical, remember, in theory, 1/2, tails, 1/2. The coin is tossed 20 times and the results are at the right. Using the results was the experiment, so I've done it. Experiment means done. 1, 2, 3 heads, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of 20, and so that leaves 9 out of 20 tails. And let's just make sure that's right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. 54. Refer to the 6-sided dice with the numbers 1 through 6. Was the probability of rolling odd numbers? There's 1, 3, and 5. So that's 3 out of 6, so that's 1/2. What is the probability of rolling a multiple of 5? So that would be 5 or 10, but that doesn't count. It's just 5. So that would be 1 out of 6. Given that the number is greater than 4, so it would be 1 out of 2, actually, because there's one possibility out of 2 chances, because the numbers greater than 2 are 5 and 6. So your answer here is 1/2. What's the probability of rolling an even number? So 2, 4, or 6. or a factor of 4. So a factor of 4 would be 1, 4, or 2. So I have 3, 6 plus 3, 6, and then I have to subtract my 2 that are the same, 2 and 4, 2 and 4. So that would leave me with 4, 6, which is 2/3. Number 57, flipping a coin 3 times. Determine if the probability is independent or dependent. It's independent. It's not going to change. Okay? In a group of students, what's the probability that 2 people have the same birthday? These are independent events. One doesn't affect the other. Selecting a marble from a bag, not replacing it, so it's dependent automatically, and then selecting another marble from the bag. A card is drawn from a standard 52 deck. Tell whether the events A and B are inclusive or mutually exclusive. So inclusive means that it can happen at the same time. So can a card be red and can a card be 4 at the same time? Yes. So it is inclusive. They don't occur separately. I will have to subtract the intersection. The card is a face card or the card is a club. This, again, I have something to subtract. I've got clubs that are face cards, so that's inclusive again. Flipping the page, so the card is black or a card is red. This is mutually exclusive. They cannot happen at the same time. The card is less than 10. The card is a red face card. Mutually exclusive. Cannot happen at the same time. Card is red. The card is not a diamond or a heart. Oh, that's mutually exclusive. Cannot happen at the same time because this would be all the red cards. That would be all the black cards. The probability of Janice smokes is 3/10. The probability that she smokes and develops lung cancer is 4/15. What's the probability that Janice develops lung cancer given that she smokes? So it says probability that she and, so I need the probability of and P and, or A and B happening. Oh, I'm sorry. Hold on. So the probability that Janice has lung cancer given she smokes. So I put the probability of A and B happening, which would be 4/15, divided by the probability that she smokes, 3/10. So I can end up changing this division to multiplying by the reciprocal, 10/3, and so that becomes this becomes 40/45, which ends up being 8/9. So my probability is 8/9. A spinner with a dial marked as shown is spun once. Find the probability that it points to an even number, given that it points to a shaded region. So an even number, probability of an even number is, so the probability of both even and odd, even number given it is shaded. So 1, 2, 3, 4, and the number of shaded ones that are even, 1, 2, 3, 4, it's 2. So that would be 1/2. Review the difference between experimental, theoretical, and subjective. Experimental, performing the tosses, performing the experiments, doing the free throws. Theoretical and theory. This is just what should happen. Subjective is just an expert's opinion. In the following diagram, math is a rectangle inscribed within a circle, or it is a rectangle with an inscribed circle. The circle has a diameter of 8, okay, and the rectangle has a height of 12, as shown. What is the probability that a dart thrown randomly will hit the circle? Okay, so diameter of 8 means that this is 8 and that is 12. So I find an area that you want to throw it in the circle. So I need to find the area of the circle.
which is my favorable outcome, divided by the area of the rectangle. So the area of the circle is pi r squared, so that would be 16 pi, which is 50.26, divided by the area of the circle, which is 8 times 12. Area of the rectangle is just 8 times 12, which is 96. So 50.26 divided by 96. So the probability would be 0.52, and that would be 52%. Use the list of the sets and refer to. So the first one says, find the set, it's the union of A and C, so I have to add A and C together. So the first part, and then I'm going to intersect that with C, which is 1, 7, 9, and 13. So the first thing I need to do is I need to add these two together. So I have a 1, I have a 3, I have a 5, so that takes that, 3, 5. I have an 11, I have a 13, I have a 15, I have a 17, and a 19. And now I want to know the intersection between the two. So what do these have in common? They have 1 in common, they don't have 7 and 3, and they don't have 9, and they have 13 in common. So this would be my answer to my set. The next one says the intersection of A and C not. So anything that's in A and C is what not in A and C is what I want. So I'm going to start marking out from my omega, which is my big set, what I have in A and C. So I have a 1, I don't have a 3, so that's going to be included. I have a 5 down here, a 7, I have a 9, I have an 11, I have a 13, I don't have a 15, and I have a 17 and a 19. So my set that is not in the union of A and C would be 3 and 15. Which of the following sets is a subset of A? So I have my subset of A is my set of A is 1, 5, 11, 17, and 19, I think. And I'm going to finish this up in the last video.